All right, thanks a lot. I'm Oded Aharonson. I want to start by saying thank you. I'm a Dor Chadash virgin, so this will probably be a night that I remember for the rest of my life. I'm thankful to Amir and Daniel for inviting me to be here. This is a real opportunity for me to share what I think will become obvious as some real excitement that I had about what I want to tell you. And the story, it's really a two-part story that is contributing to my excitement. The first is has to do with the inspiration that comes about when mankind sets their dreams, and sometimes outrageous dreams, and converts them to actions and eventually to a successful mission like the one that I'm going to talk about. So whenever there's an accomplishment like that, I think it is a real tribute to humanity. The second is the fact that in this particular endeavor, we actually ended up exploring, finding and unveiling a world that's remarkably similar to our own. It's probably more similar to Earth than any other world that we've ever found, and we've only discovered that in the last few years. Where's my clicker? So let me tell you about this place that's both strange and familiar. By the way, this is Titan over here, casting its shadow on Saturn. It's a picture that was taken from the Hubble Space Telescope a few years ago. And more or less, this is all we knew about Hubble. It was just this sort of, about Titan. It was this icy satellite that was veiled with an atmosphere that we couldn't penetrate, we couldn't see through. So we sent a spacecraft there. Voyager flew by and took this picture that you see over on the left, and we were able to figure out that there's stuff in the atmosphere that's a lot like Earth. It's like a bar and a half, 1.5 times the Earth's atmosphere, made mostly of nitrogen, just like Earth. But again, we couldn't see through it. All we could see is that it was a world that looked a lot like Earth, Venus, Mars, that you see here in the rest of the slide. But it wasn't like all the other icy satellites around the solar system. And that's more or less all we knew. We did experiments in the lab. This was in the basement at Cornell, where I went to school, where people took methane and nitrogen and put it together in test tubes and tried to make the kind of compounds that we see in Titan's atmosphere to try to figure out what it was made of, what gave it this orange color. But it wasn't until Cassini launched, if you could see, this is an old style picture over in the corner. You can see the date actually imprinted on the analog picture. It's October 1597 when Cassini, in the spectacular night launch, took off towards the outer solar system. And then it all changed. Cassini got to Saturn and deployed this Huygens probe that descended through the atmosphere and started showing us all these amazing things about this world. First thing we now think happens on Titan is that it actually has a liquid water ocean, like the one you see there. It's probably one of the few other places in the solar system where there's actually a large body of subsurface ocean where life might even exist. It also showed us that Titan has dunes. So you have to understand, Saturn is 10 times further from the sun than Earth, and therefore gets 100 times less sunlight. So it's really cold there. It's 200 degrees below, as Daniel mentioned. So when we got there, we really didn't know what to expect. Everything seemed so different. The materials were different. Water ice is as hard as rock there. And yet when the pictures started coming in, we saw these features that were strangely familiar, things that people here on Earth see all the time. In fact, I'm heading to the Sahara Desert in a couple of weeks to go check out analogs to Titan, because you see this picture of dunes. They're called longitudinal dunes. They're a couple of 100 meters apart and several tens of meters high. And here is a picture that a shuttle astronaut took from the window of the shuttle with his handheld camera, and you see the remarkable similarity between the Namib Desert and Titan, this place that's 100 times colder. So if the dunes aren't enough, here's some channels on Titan, and you see that these channels are braided and they merge together and they form networks. And if you've ever flown over, especially the western side of the United States, you can see things that look a lot like that, right? You see channels that are braided and come together. And this is a world all the way out, 100 times colder in a sense, receives 100 times less sunlight than the Earth, and yet it has this liquid flowing on the surface. Nobody had ever imagined that we would find geology like this. So water is as hard as rock there, it's ice. So what could be flowing on the surface? The answer is methane. So methane is near its triple point at Titan, much like on Earth, water is near its triple point. So there's an opportunity for methane to evaporate and precipitate and rain and drain and form channels and lakes the way that water does on the Earth. So it's a place where we have things that are really reminiscent of the things that we see here on Earth, but at vastly different temperatures. This is Cassini letting go of the Huygens probe. Can we turn it down a little bit? So you see Huygens, this is a part of the spacecraft that the Europeans built, separating from the spacecraft and descending through the atmosphere of Titan. The descent sequence takes a couple of hours from beginning to end, but near the end, a lot of stuff happens really quick. You see that there's a heat shield that protects the probe from coming in at supersonic speed through the atmosphere. That the spacecraft separates from the heat shield, and first there's a parachute that separates. You'll see that in a minute. The first of 3 parachutes, it slows the spacecraft below supersonic velocity. There goes the heat shield, and then the spacecraft sends a second parachute. The first parachute would actually be too big because the atmosphere is so thin. It would take forever to land with that big parachute. So we actually need a set of 3 different parachutes to land on this other world. There's a radar that acquires the surface of Titan. And then finally, the last parachute deploys and the lander comes to rest at the surface. Now you have to understand, as scientists, we had no idea where we were going to land. Okay, we sent this probe out there, and we had to design it so that it could land in anything. We didn't know what was under those clouds that we saw from the spacecraft pictures. So there were all sorts of questions on what it was that we were going to land in. And this is of course an animation, a cartoon. Here's what the whiteboard at Caltech was when on landing day on Saturn. So we had a betting pool of what different people thought we would land in. Some people thought we would land in ice. Some people thought we would land in this hydrocarbon tar, basically this sticky stuff that is making up all of these hazes in the atmosphere. One person thought we would land in liquid. A lot of people thought it wouldn't be determined what we landed in, that we would never know. This is one of my students. Another one of my students shares my skepticism apparently, and he thought he would be dead on arrival. And one of the most famous Caltech professors thought he would be eaten. What we actually did land in is this. This is an outflow channel that you see from the mountains over here emptying into the basin. And this is the picture that the lander took when it hit the surface. Okay, so this is a picture from the surface of an icy satellite orbiting another planet all the way out at the end of the solar system. I hope you share with me the tremendous amazement at the feat of humanity and of accomplishing this. So I already mentioned that Titan has a hydrologic cycle where liquid methane plays the role of water and can condense in the atmosphere, rain down, and form lakes. And the lakes are really sort of my baby. So we realized that there are a ton of lakes in the northern hemisphere of Titan and only a few lakes in the south. And we were trying to understand why are all the lakes on one side of the planet and not the other. And it turns out that this is also in perfect analogy to what happens on Earth. The explanation for this is much like on the Earth, where the ice ages come and go cyclically as a result of orbital cycles. This is a theory that 2 guys by the name of Milankovitch, who you might have heard of, and actually a little bit before him, James Coral, suggested that some of the climate change that we see every day outside, some of it people probably caused. That's of course a big debate, the anthropogenic effect of climate change. But some of it is also cyclically caused by the motion of the planets tugging on one another. And it turns out that Titan has exactly the same thing going on, if my theory is right, it remains to be seen. It has exactly the same thing going on, much like ice coming and going from the high latitudes of the Earth from pole to pole. On Titan, the methane moves from pole to pole. And at the moment, we just happen to catch it all in the northern hemisphere. But if we waited, it would be in the south. And as Titan goes around in its orbit, and this is what this little animation is supposed to show, as Titan goes around in its orbit, the methane molecules that you see bouncing around are transporting from pole to pole. So Titan actually goes around the orbit of Saturn, so it's really along for the ride. Whatever Saturn does, Titan has to do too. So if any of you have any experience in partner dancing, you'll recognize this. Titan and Saturn are really locked in this dance around the sun. They orbit around each other. And I see I have one dancer over there. And really, anything that Saturn does, Titan is along for the ride. And it's really Saturn's seasonal variations that are mirrored in the lake distribution on Titan. So it's really quite a beautiful system that is executing all this. I'm going to end with this. Actually, I think I have a couple more slides. This one and maybe one more. This is an animation that we did of one lake in the south. This is called Lake Ontario because it's sort of the same size and shape as the one that you probably know. It's a lake, the one big lake in the southern hemisphere of Titan is called Lake Ontario. And you see a lot of similar things that you might be used to from seeing the Earth. This is from a press release that we called Postcards from a Lake on Titan, because you can imagine going on vacation on a lake in this other world. You see that there are shorelines that are bounded by mountains on this side of the lake. Further down, there's a wave-cut beach, and on the other side of the lake, which we will pan to in just a little bit, there's actually a delta, a place where a river delivers all of its sediment and dumps it into the river into the lake. Here is the delta right here, just like say the Mississippi River Delta is at the termination in the Gulf. So you see strange but familiar characteristic, a world that's 200 degrees colder, all the materials are different, water is as hard as rock, methane is liquid, everything is weird, but we go there and we find rain and lakes and channels and climate change, all of these things that are strangely familiar to our own planet. So I think it's important to realize that, you know, somebody asked me, I sat down with somebody I hadn't met before, and before the session today, and they asked me, so how does any of this matter to me? How is this going to affect my life? The answer is it probably doesn't. I mean, probably none of you are ever going to be affected by the fact that we now have additional knowledge about this strange but familiar place in the outer solar system. But I do think, I have two comments to make about that, and that, I think, first of all, it helps us understand our place in the universe. It's sort of an intellectual pursuit that is important for humanity to undertake, because that's, in a sense, what separates us from animals. It's in a sense, it's the luxury that we have to ask questions that aren't survival questions, but really support questions of pure knowledge. And these comments are also applicable, I think, to music and to art and maybe to sports, where we do things for the benefit of advancing the intellectual or the beauty of humanity, and not just for benefiting, not that there's anything wrong with curing cancer, but not just for curing cancer or winning wars. So in that spirit, we're proposing another mission to Titan now. Actually, I'm part of a team that's proposing a lake lander. This is, in a sense, going back to the roots of exploration on Earth, where people used to explore the Earth by taking ships around. We want to send a ship to Titan and land it in one of those lakes and make a measurement of the composition and the rates at which it's evaporating and raining. One of my colleagues was actually sitting at the NASA administrator's office, where James Cameron was also present, because he's a team member on another project going to Mars. He's part of the stereo camera on board the rover, and asked me about that. I can tell you a whole bunch about that. But you know, we realized that James Cameron, after making a movie about ships, and also doing another one about extraterrestrial worlds, where Titan is mentioned, by the way, would be a great person to support this ship on another world. Thank you very much.